Hello guys, so I'd like us to look at how to differentiate this function here. Y is equal to sine x minus 3 over x plus 2. Now, what is most important is for us to be able to identify which method of differentiation we are going to use. As you can see here, this is a sine function, and inside it we have an algebraic function. So obviously we're going to use chain rule. So using chain rule, the solution, we're going to let that which is inside the bracket be our u. So I'm going to have my u being equal to x minus 2, x minus 3, x minus 3 over x plus 2. Then I'll go ahead and find my du dx. So if I am to differentiate this function here, I'm going to use the quotient rule. So let the function up here be u, let the one on the denominator be v, and using the quotient rule, we'll have u prime v minus v prime u, all this divided by v squared. So this is going to give us du dx is equal to our u prime. If you differentiate x minus 3, you get 1, multiply it with v, which is x plus 2, minus, if you differentiate x plus 2, you get 1, multiply it with u, which is x minus 3. All this divided by v squared. Our v is x plus 2, then we square it. So this is going to be our du dx. Now recall, chain rule, getting dy dx is equal to dy dx, but with respect to the new variable u. So ideally what we'll be doing is getting dy du dx. We already have our du dx here. So we need to get dy du. So in order for us to get dy du, we need to write y in terms of u. So come and look at y. The whole of what is in here is u. So my y can also be expressed as sine u. So let's come and have it down here. So y is equal to sine u. So what is dy du? Differentiating sine u, we get cos u. So what's our final answer? So my dy dx is equal to dy du, which is cos u, multiplied by du dx, which is this over here. So I'm going to open the bracket. In the numerator, I have x plus 2 minus x plus 3. All this divided by x plus 2 squared. Okay, then this is the same as, so our final answer should not be having u. So we will write back what u is, cos of u, and our u was x minus 3 over x plus 2. So cos of x minus 3 over x plus 2, and this is multiplied with x and x will go, 2 plus 3 will give us 5, so over x plus 2 squared. So this is the same as us having, writing this properly, it's the same as us having it as 5 over x plus 2 squared cos of x minus 3 over x plus 2. This is our answer. Now, we could have used the shortcut of chain rule to get this simply. So down here, I want to use the shortcut the other way using shortcut. So we have our y being equal to sine of x minus 3 over x plus 2. So we say using the shortcut chain rule, differentiate the whole of this function, y dx, differentiate sine, the whole of the sine function. So if you differentiate sine, you get cos. So I'll have cos of x minus 3 over x plus 2. Then besides it, multiply with the derivative of what is inside. And what is the derivative of this which is inside here? The derivative of this will be u prime v minus v prime u over v squared. So ideally, if we do that, we already did it, but we can do it again. We have cos of x minus 3 over x plus 2. And then the derivative of what is inside. So if you get this, let it be your u, get this, let it be your v. Your u prime is 1, your v is x plus 2, minus your v prime is 1, your u is x minus 3. All this divided by v squared, which is x plus 2 squared. And if you open this up, you will obviously get the same answer that we got up here. Okay, so this is going to be cos of x minus 3 over x plus 2. And then on this other side, this is x plus 2 minus x, so the x will give you a 0. This is 2 minus minus, so that will be plus 3. That will give you a 5 over x plus 2 squared. Same answer as what we got up there. So that's how we go about it.